Here we go. Good afternoon, ladies and gentlemen. So, what we're going to do is we're going to talk about what can't X be? What can't X be? Now, in this case, if I have 1 over X, what can't X be, studio audience? It can totally be 1. 1 would be okay because 1 over 1 is 1, and I'm okay with that one. It can be any other number. 1 over 2 would be 1/2. That'd be okay. What can't X be? 0. It cannot be 0. Ladies and gentlemen, it can't be 0. Nathaniel's the winner for the day. It can't be 0 because that's true. There we go. Because if I try to take 1 divided by 0, what is 1 divided by 0, Mr. Chalmers? It would not be 0. 1 divided by 0, if you try putting it in your calculator, what do you get? Error. Very good. Now, 0 over 1, I'm good with all day long, but 1 over 0, no dice. So 0 cannot be in the denominator. So if I have this, 1 over X minus 3, what do you get? What can't X be? X can totally be 0. See, it's a trick question because 0 minus 3 would be -3. 1 over -3 is okay. So what can't it be? 3. It can't be +3. Why can't it be +3? All right. So what it can't be is it cannot be 3. It cannot equal 3. 3 minus 3 is 0. 1 over 0. No good. That is bad. Okay. So you can't have that. Now, what we need to talk about is what about in a situation like this? X minus 4, X minus 7. What about that?
0 can't be 4 or 7.
Oh, X can't be 4 or X can't be 7 because both of those would make it 0. I got 1 over 4 minus 4 times 4 minus 7. So even though I get 1 over, I get 0 times -3. But what's 0 times -3? Still 0, so it's still bad. It's no good. Okay, so and the same thing would happen for 7. So what can't X be? Now, this is a little tougher. Why is it a little tougher? Has an exponent. Okay, what else? In this case, I have 3 bits. What do I need to do with those bits? Break them up. X plus 1 plus 2. Could I do that? Now who can tell me what X can't be? X cannot be -1 and X cannot be negative. So when I factor, it makes it super easy to tell what X can't be. Let me show you the reason why it can't be that. If I were to take this and graph this, the graph of this looks like this. That's what the graph of this equation looks like. You'll notice I have these dotted lines here. These dotted lines are called what? Does anybody know? A line that the graph approaches but never touches. Asymptote. 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 Okay, an asymptote is a line that the graph will approach but never ever touch. Okay, the idea is if I made my way halfway from me to Davis, okay, and then I said, let's cut that distance in half, and let's cut that distance in half, cut that distance in half. Will I ever touch Davis? No. Thank God, no. Okay, because whatever the difference is, I'm still only going halfway to him. And so I'm approaching Davis, but I would never, ever touch him. So that's the idea here. It's coming down towards 0. So I have vertical. What does vertical mean, folks?
Up and down.
Up and down. Okay. So I have vertical asymptotes right here, the ones that they can't touch. But also, I have a horizontal asymptote. And the horizontal asymptote happens at y equals 0 because it's not going to touch 0. All right, now let's do one more problem. I have 1 over x plus 2 plus 3. Now, first of all, where's my vertical asymptote going to be? What can't x equal? Close, -2. So it can't equal -2, so I'm going to have a vertical asymptote there. Do you buy that? Now, normally my horizontal asymptote would be at 0. Who can tell me where my new horizontal asymptote is going to be in this problem? Why 3, Miss Smith? Do I have a plus 3? So if I take and put a plus 3 on the end of any graph that we've ever done, what has plus 3 done? Moves it up 3, right? If I put a -3 at the back of any graph I've ever done.
Down 3.
Right. Okay, so in this case, 1, 2, 3 has a horizontal asymptote here. So my graph looks like this. It doesn't cross this line. It doesn't cross this line. So you have a vertical asymptote at x equals -2, horizontal asymptote at y equals 3 because it's moved up 3. Okay, that's all we need to talk about for that one.